Hello, in this video I'll be showing you different ways of writing code to generate nth number of Fibonacci series. If you don't know what Fibonacci series is, I will give you a link to Fibonacci series in Wikipedia. I'll also explain in simple terms. Fibonacci series is generated by adding last two numbers in the same series. For example, it starts with 1 comma 1, and then the next number is generated by adding the previous two, which is 1 plus 1 equal to 2, and then you have 3, and then you have 5, 8, 13, 21, and it goes on like this. Okay, so we'll be writing code to generate nth number in this. There are multiple ways of doing it. I'll show you different ways of coding them, and then you will learn certain things from them. Let's start. Okay, we need to get nth number that we will be generating. We need to have stream space std. We will be putting Fibo of n. Okay, so we'll implement this Fibo. Since the Fibonacci number can be big, we'll have to use long instead of int, so that it can hold values up to 2 power 64, 2 power 63 actually. Fibo of int n. So yeah, if n is less than 0, it's not a valid input, so we'll be returning -1 to represent that the input is invalid. And if n is less than 2, then we'll return n. Let's index the numbers. This is indexed 1, 2, 3, 4, 5, 6, 7, 8. And then we have to have long previous, which is 0, that is 0th index, previous, and then current, which is 1. This is for the first one. Then you start iterating from 1 up to n. Int I equals 1, and I is less than or equal to n. Yes. 1 is already computed actually. Let's go to long Fibo of Fibo is equals previous plus current, and then you have to update the variable for the next iteration, current, and then you have current equals Fibo, and then you can return current. Yeah, let's see if this is generating the right answer. Okay, we have to get for, let's say we'll get for 6. Yes, we're getting the right answer. And then 8. Yes. So this is iterative approach to generate Fibonacci number. Another approach to generate Fibonacci number is by recursion. That is, instead of running a for loop, we will call the Fibonacci series for the previous and the one before that. So let's write another function to generate that. Let's rename this to iterative, and then we'll write another function generated by recursion. The end. Okay, again the same edge cases. Return -1 if n is less than 2, return return n, and then we have to return of n minus 1 of n minus 2. So this is exactly what Fibonacci means. Get the Fibonacci number of n minus 1 and get the Fibonacci number of n minus 2, add them together, you get the nth number. This is the definition of Fibonacci number. Let's try running this. Let's try 7. This is 30. That is correct. And then let's try 3. Should get 2. Yeah, this is also working perfectly fine. But the problem with this approach is that the order of the solution is 2 power n, which is every call to this function will call 2 of the same function. So at every level, it will the number of call to the function multiplies by 2. If you call it for, let's say, n equal to 50, we will be calling this function almost equal to 2 power 50 times, which is a lot. Computer can process up to 10 power 8 number of instructions within less than the time that we can perceive. If it is more than that, it will be the delay will be big enough that humans can perceive it. So let's try running it for 50. Then you will see what I'm saying. So when I ask it to find the Fibonacci number for 50, it's trying to call itself to the power 50 times. So as you can see, it didn't even generate the answer. It gave up because it is taking too much time. Online compilers will kill the process if it is taking too much time. It assumes it goes into a long infinite loop. Okay. So to fix this, there is a simple solution. That is, if you have generated solution for, in this, we are not generating solution for more than 50 numbers. So the maximum number of solutions that we have to find is just 50. But the problem is we are generating solution for this same number multiple times. So we can avoid this by remembering the answer that we generated. That can be done using a global variable. Let's call this global variable dp. You can read about this later. So let's say we have to generate answers for up to 1000 Fibonacci numbers. Let's say the input only up to 1000 is allowed. So we will put another condition that if n is greater than or equal to 1000, we return -1, and then we find the answer, and we have to initialize dp. P of I equals -1, and then let's initialize check if we have already found solution for nth number. Dp of n is not equal to -1, then we can return the answer, which is dp of n. And then we store the answer for nth number after generating it by doing of -2. Store it, and then so what happens in this case is once we find the answer here, we store it in that variable, and the next time we enter this same function for the nth number, we will we will return it directly there. So let's try to run this. So for this, if we call 50, we still get answer because it is not computing the same answer multiple times. Okay, this I will save this code in the link so you can try. Thank you.